What's up, people? I got this cylinder right here. It says 500 grams on it. It says this thing has a mass of 500 grams. Go ahead and tell me what the weight of this mass is. Go ahead and tell me what the weight of this cylinder. How much does it weigh? Well, if you said 4.9 newtons, you're bang on. Look at that. That right there is 5 newtons. 4.9 right on it. Got it hanging down there. Pretty cool. Went ahead and made this sled right here. It's just a block of wood with a hook in it. And I put on there 500 grams, 300, 200. I put on 1,000 grams or a kilogram. What I'm going to end up doing is taking this spring balance scale that has units of newtons, attach it to the sled, and then pull it, and we'll be able to see what kind of friction these different surfaces are. So we're going to do this table, the ground, the floor, and this wooden shelf right here. So there's three different surfaces that we're going to test. So go ahead right now and tell me your hypothesis. No wrong answers, but I just want to see what you guys think. Which surface is going to be the smoothest or the least amount of friction? Tabletop, floor, or wooden shelf? So we have two different types of friction. We have our static friction and we have our kinetic friction. The formulas for these, we've gone over them plenty of times, so I'll go ahead and write them out. It's the coefficient of static friction times the normal force. Now we have coefficient of kinetic friction times the normal force. All right. And just a quick reamp on the normal force. The normal force is the force that whatever surface there is pressing back up on the object. So remember that bottle of poison, right? We had that bottle of poison sitting right here. That has a weight pressing down on the table, and the table is actually pressing back up with the normal force. If the weight and the normal force are both acting on the bottle, but the bottle's not moving, then that means that the normal force is equal to our weight. So, for the sled, it has a weight of 1 kilogram. If our weight is equal to mass times gravity, and our mass is equal to 1 kilogram, and gravity is equal to 9.8, then it has a weight of 9.8 newtons. And if weight is equal to normal force, that means that the normal force is equal to 9.8 newtons. What's going to happen is that we can use this right here and plug it into these two equations. Bang, bang. All right, so I'm gonna drag the scale across the surface. It's going to give us an answer in newtons. It's going to show us something in newtons. And we're going to plug that into here. We're going to plug that into here, right? So for example, let's say we get something that shows us 2.1 newtons, right? Let's say that's the kinetic when it's moving. It shows us 2.1. That's going to equal our coefficient of kinetic friction times the normal force, which is 9.8. We just simply solve for our coefficient of kinetic friction, and it'll tell us how slippery an object is, how much friction it has, and we're going to do that for each surface. All right, so I have it attached to the sled. First up, static, so it's not going to move. How much? Right before that threshold, right before it moves. Let's see, right there. That looked to be about, hang on a second, bring it back. To be right about 4. So right about 4 newtons for the static. Now for the kinetic, I'm going to pull it across the screen at a constant speed. 2.5. 2.5 for the kinetic. Now we're on the shelf. All right, so static for the shelf. All right. It's looking like that's going to be about 4.5. Let's try one more time and see. 4.5 for the shelf. Now kinetic for the shelf. It's at 3. So 3 newtons kinetic for that shelf. All right, now we're on the floor. So let's look at static. Five for static for the floor, and then let's look at kinetic. .5 for the floor for kinetic. Very good. So hopefully your hypothesis was right. If it's wrong, that's all right. That's what it means to be a scientist. Let me know.